As now we're at 6-2, day 2 of polynomials and linear factors. The objective for today is to factor and identify the zeros of a function, and also then to write a polynomial function given the zeros of that function. Before we proceed to the first example for today, let's talk about relative min and max. We have touched on this before, but we haven't spent any time really with it, and we're not really going to go into too much in-depth detail here, but I still wanted to at least explain to you what it is before we proceed. All right, so relative min and relative max are the points within a region that where the graph turns from a increasing to decreasing and decreasing to increasing, basically. So right here the function is decreasing, and at this point it turns and it's increasing, and then it turns again and it's decreasing. So these are your relative min and relative max, because this is the highest point and this is the lowest point. And with the exception of these two mins and maxes, this function, this relation, this graph, is going on in opposite directions forever. So there is no other place where it changes direction. So that is why it is called the relative min and max. And it makes sense. Relative min, that's your lowest point, right? Relative max, that's your highest point as far as this little area goes. Okay, so let's go ahead and take a look at the next example. That's it. That's all I wanted to talk about with this. So finding the zeros, but we're going to find the zeros and not graph this, which is going to immensely decrease the complexity of this particular problem. And the reason we're not graphing it is because you won't be able to do it without the graphing calculator at this point in time, and that would just take more time than what would be beneficial to you. All right, so when we are given a function that is simplified like this, that's awesome. We just use that zero product property and we identify what those zeros are. So x minus 2 is 0, x plus 1 is 0, x plus 3 is 0, and solve each expression for x. So x is 2, x is negative 1, x is negative 3. Okay, so now taking a look at this one, this should hopefully be very easy, and hopefully nobody balks too much at this. Because it's already factored for us, we know that we can just set each of those expressions equal to 0. And I'm not sure why I used parentheses on that first one, except that it was up here. You don't have to, obviously. And so now solving each of these for each of these for x, we're going to subtract 1 from this first one. So then we have x is negative 1. We're going to add 1. And so then you have x is 1. And then we're going to subtract 3 from both sides. And you have x is negative 3. So the zeros of this function, so you're going to say you have zeros at negative 1, 1, and negative 3. That would be the answer to your solution, or to your question, to your problem. Now, what happens if you have, and I'm going to go ahead and scroll down, something that looks like this: y equals x minus 2 cubed, x plus 1 squared. And let's throw in an x. We're really complicating this thing, right? Okay, so what this means, if we expand this, is x times x minus 2, x minus 2, x minus 2, x plus 1, and x plus 1. Because we have the x, we have 3 of these, so x minus 2, x minus 2, x minus 2. We have 2 of these, So we have x plus 1 and x plus 1. Now, you set each of these equals 0, right? And solve for your x. So this one you have x equals 0. That's it, you're done. This one, you can either write x minus 2 equals 0 3 times, or just x minus 2 equals 0. X plus 1 equals 0 2 times, or just x plus 1 equals 0. So this one's already done for you. And then you add 2 to both sides, and you have x is 2. Subtract 1 from both sides, and you have x is negative 1. Okay, so now we are going to go ahead and take a look at writing the equation given the zeros, but we're going to revisit what these different polynomial or what these different exponents mean. But hopefully seeing it expanded like this and having it connected with this might make it a little bit easier. But the zeros of this particular equation are x is 0, x is 2, x is negative 1. Okay? All right, so now let's go ahead and take a look at example 5, the second example for today. And we have writing a polynomial function from its zeros. So we're given the zeros. Now, what that means is that we had x is negative 2, x is 3, and x is 3. So you need to then add 2 to both sides, and you have x plus 2 equals 0. Subtract 3, and x minus 3 equals 0. Same thing. And now you can see that you have your expressions, x plus 2, x minus 3, x minus 3. And that's where those come from. Now, some of you are going to be able to quickly see the connection here. So this was negative 2, that becomes positive 2. This is 3, that becomes negative 3. This is 3, that becomes negative 3. You take the opposite of what that is because you were solving it for 0. But this over here is why it works out that way. So you can do it either way. You can think of it either way. Obviously, understanding this property, this rule, what's going on over here, and then applying it saves you some time. But until you get there, if you want to do this, there is nothing wrong with that. This may actually help you understand and get a very good foundation of that. All right, so then what you do is you multiply it out like we did with example 1 and 2, and just make sure it's in the proper standard form. All right, so we have zeros at 2, negative 3, and 0. So that means we have a 0 at x is 2, we have one at x is negative 3, and we have one at x is 0. So we're going to subtract 2, and you have x minus 2 is 0. We're going to add 3. So then you have x plus 3 is 0, and over here you have just x is 0. So y equals x minus 2 times x plus 3 times x. All right, I'm going to multiply the binomials together. So we have x times x, which is x squared, x times 3, which is 3x, negative 2 times x, which is negative 2x, and negative 2 times 3, which is negative 6. Putting parentheses around that, and then multiplying that by x. We need to simplify the middle two terms, which is going to give us a positive x, because positive 3x minus 2x is just positive x. So you have y equals x squared plus x minus 6 times x. X squared times x is x cubed. X times x is x squared. And then negative 6 times x is negative 6x. So the polynomial in standard form, when you have zeros at 2, negative 3, and 0, is going to be y equals x cubed plus x squared minus 6x. Decreasing order of the degrees, so we got this. All right, the last example that we have is going to touch back on what we did with example 4. And this one is looking for the multiplicity of the zeros. So it says find any multiple zeros of the function f of x equals x to the fourth, 6x cubed plus 8x squared. So the first thing you want to do is factor out any like terms. So this ties in, like I said, very, very, very closely with example 4. But it also ties in with example 2 that we had done from 6-1 day 1. So looking at these, they each have x squared in common, so you factor out an x squared, which is what they've done here. And that leaves you with x squared plus 6x plus 8. So then you factor that x squared plus 6x plus 8 down, and you get the x plus 4, x plus 2. So you set each of these expressions equal to 0. X squared equals 0, x plus 4 equals 0, x plus 2 equals 0. So then you have a 0 at 0, a 0 at negative 4, and a 0 at negative 2. And you have 2 zeros at 0 because you have that degree 2, that power of 2, which is what they have here. So the number 0 is the multiple 0 of the function with multiplicity of 2. All right, so let's take a look at this one for your notes. And this will be the final example that we have. So f of x equals x to the fifth minus 6x to the fourth plus 9x cubed. So f of x equals x to the fifth minus 6x to the fourth plus 9x cubed. Ignore that. Okay, so this has x cubed, x to the fourth, x to the fifth. So I can factor out at least an x cubed, which then leaves me with x squared minus 6x plus 9. Okay, so 3 plus 2 is 5, 3 plus 1 is 4, 3 plus 0 is 3, so we're good. Now, what are the factors of 9 that give you negative 6? In this case, that's going to be negative 3 and negative 3. So we have x cubed times x minus 3 times x minus 3, or x cubed times x minus 3 quantity squared. All right, so this right here tells us that we're going to have 3 zeros at this particular, wherever this x is 0. And this one tells us we're going to have 2 zeros wherever this x is 0. So we set each of these equal to 0. X equals 0, x minus 3 equals 0. Add 3. And you have x is 3, and this one is x is 0. So x is 0 with a multiplicity, and I just abbreviate mult of 3. This one had a multiplicity of 2, so I put mult of 2. Now, if this is confusing, you can expand that out so that you have x times x times x times x minus 3, x minus 3, and set each of these expressions, each of these terms equal to 0. So then you have x is 0, x is 0, x is 0, x minus 3 is 0, and x minus 3 is 0. So obviously you have 3 zeros at 0. So you have a 0 at 0, multiplicity of 3 because it happens 1, 2, 3 times, and you have a 0 at positive 3 with a multiplicity of 2. So either way of working these out is acceptable. The red method might be more easier to see to begin with, to start out with, and then eventually do it the way that we have over here. All right, that's it for 6-2. Hope that makes sense. If you have any questions, let me know.